In this example, a country is planning changes in its tax structure in order to provide a more equitable distribution of income. So the two Lorenz curves that they have, their current one is f of x is equal to x to the 2/3 power. And the proposed one is g of x is equal to 0.4x plus 0.6x squared. And the question is, will the proposed changes work? So in order to answer this question, we have to determine which of the two Lorenz curves produces a more equitable value for the income distribution. In other words, which one of those two yields a smaller Gini index, one that's closer to 0. So let's first take a look. Oh, I can't use the highlighter there. Let's take a look at the Gini index for f of x. Okay, so remember that the Gini index is equal to 2 times the integral from 0 to 1 of x minus f of x dx. Okay. So in this case, we have 2 times the integral from 0 to 1 of x minus x to the 2.3 power dx. Okay. All right, so we're going to go ahead, take the antiderivative. So we've got 2 here, and then we're going to take x to the 1 plus 1 over 1 plus 1 minus x to the 2.3 plus 1 over 2.3 plus 1. And all of this is going to get evaluated between our limits of integration, which are 0 and 1. So when we do this, okay, we're taking 2 times, okay, well, we have 1/2 x squared, okay, all right, minus, and then we've got 1 over 3.3 times x to the 3.3, okay, and then evaluating that between 0 and 1. All right. So before we go on and start calculating this out, I'm gonna convert 1 over 3.3 to a decimal. I'll go out to 3 decimal places here. So we've got 2 times 1/2 x squared minus, this is 0.303. It's approximately what 1 over 3.3 is, times x to the 3.3, evaluated between 0 and 1. So now I can go ahead and take a look. When x is equal to 1, then I have 1/2 times 1 squared minus 0.303 times 1 to the 3.3. Okay, well, that works out to be 1/2 times 1 squared. That's just 1/2. That's 0.5. Minus, then I have 0.303 times 1 to the 3.3 power. 1 to any power is just 1. So this is minus 0.303. Okay. And when I calculate that out, that becomes 0.197. And then when x is equal to 0, I have 1/2 times 0 squared minus 0.303 times 0 to the 3.3. Well, that's just all equal to 0. So for the Gini index here for f of x, I have 2 times 0.197 minus 0, which gives me a Gini index of 0.394. Okay. Now I need to calculate out the Gini index for g of x, the proposed structure, and see if that produces a smaller number. So move down here. So we're going to find the Gini index of g of x. Okay. So again, this is going to be equal to 2 times the integral from 0 to 1 of x minus g of x dx. So this is going to be 2 times the integral from 0 to 1 of x minus, now I have to put my function in parentheses because the negative is going to apply to every term in g of x, which is 0.4x plus 0.6x squared, then dx. Okay. So now I can go ahead and I can put like terms together. But first I'm going to distribute this negative into parentheses. So I have a negative 0.4x and a negative 0.6x squared. So this becomes 2 times the integral from 0 to 1 of negative 0.6x squared plus 0.6x, because when I take x plus 0.4x, or I'm sorry, x minus 0.4x, that's where I get the 0.6x. Now I can take dx. All right, so I'm going to go ahead, figure out my definite integral here, take the antiderivative. So I have negative 0.6 times x to the 2 plus 1 over 2 plus 1 plus 0.6 times x to the 1 plus 1 over 1 plus 1. And I'm going to evaluate that at my limits of integration between 0 and 1. Okay, well, 2 plus 1 is 3, okay? And I can cancel the 3 with the negative 0.6 to get a negative 0.2. And on the other term, the 1 plus 1, that equals 2. I can cancel that with the 0.6 to get 0.3. Okay. So I'm taking 2 times negative 0.2 x cubed plus 0.3 x squared that I'm going to evaluate between 0 and 1. So when I take x is equal to 1, that means I take negative 0.2 times 1 cubed plus 0.3 times 1 squared. Well, that becomes negative 0.2 plus 0.3, so that gives me a positive 0.1. And then when x is equal to 0, I have negative 0.2 times 0 cubed plus 0.3 times 0 squared. That's just equal to 0. So when I evaluate this, I have 2 times the value of my expression at 1, which is 0.1, minus the value of my expression at x equals 0, which is 0. And here, my Gini index is 0.2. So let's take a look. Our original Gini index is 0.394. Our new Gini index is 0.2. So the answer to the question is, are these changes going to work? The answer is yes. Okay, the changes will produce more income equality. Okay.